by going from studying what happens to one initial state to studying what happens to a distribution in initial states, we're doing something very physical, which is to say that we never know any state with infinite precision. Mathematicians might know it sometimes, but in science, applied dynamical systems, there's always some uncertainty about initial states. There's also uncertainty about laws of nature. We pretend that Newton's law is immutable, eternal, etc., but it's not quite true. We know that all our laws are approximate and, good approximation, certain level of approximation. Now, if you understand this and a few things that will happen in this course, you will understand foundations of statistical mechanics. Because so far we have taken a state space and we have fibered it in a fiber bundle of trajectories, Lagrangian spaghetti. And every spaghetti has, you take a point on it, just a label. It says, this is 17 spaghetti. This is what it is at time t0 or something. But it's really only a label. The object is the whole invariant orbit. And that orbit has past and future. So, a great puzzle of determinism is why is it if you know everything about past and future, we cannot see future as in a mirror of the past. Why is it that we can go back and forth? The moment you start talking about neighborhoods, you'll realize in very simple dynamical systems, you will understand that you cannot go back. You can go back for finite time. It's called Lyapunov time or something, and you cannot go beyond Lyapunov time. And you just can't do it. And the reason why you can't do it is the same why you can't beat the housing bubble, the stock market, etc. Exponential growth is unsustainable. And what's very typical of dynamical systems is that all the errors generically tend to grow exponentially. That means in finite time, no matter how many computers you have, you won't be able to predict. And you will never be able to predict weather beyond, let's say, 10 days, no matter how accurate your measurements are. Just because it's intrinsic even to 3 degrees of freedom and not 10 to 24 like we think in statistical mechanics or some such number. So this is going to be all totally innocent, but it's actually a fundamental shift.